Welcome students. Today we are going to start session number 6 of light reflection and refraction of class 10th science. So let us start with the today's topic, that is refraction of light. We know that light travels in a straight line path. This is true as long as light rays are traveling in the same medium, right? अगर light same medium में travel कर रहा है, so it will travel in a straight line, okay, having the same density throughout. If however the light rays are made to go from one medium to another, the light rays change their direction, or we can say it bends at the boundary between the two medium. For example, when a light ray traveling in air, when it goes obliquely into another medium, say water or glass, it changes the direction on entering the glass block or water. The change in direction of ray of light, or change in direction of ray of light is also known as bending of ray of light, occurs again when it goes out from water into air or glass into air. Okay, so the change in the direction of light when it passes from one medium to another is called refraction of light. So this is the definition of refraction of light. In other ways or words, we can say that bending of light when it goes from one medium to another obliquely is called refraction of light. The refraction of light takes place when light rays enter from air to glass, or from glass into air, okay, or air into water, or water into air, okay. So now let us see what are the causes of refraction. Bending of light क्यों होता है? Actual में the speed of light is different in different medium. For example, the speed of light in air is 3 into 10 to the power 8 meter per second, and the speed of light in glass is 2 into 10 to the power 8 meter per second. So दोनों मीडियम में जब लाइट का स्पीड अलग है, so definitely when it travels from one medium to another, it will change its path. Either it will bend, that we will see how it will bend. So the speed of light is different in different medium. For example, already I told you, therefore the light travels faster in air but slower in glass, okay. And the refraction of light is due to the change in the speed of light on going from one medium to another medium. Thus, uh, when light goes from one medium to another medium, its speed changes, and this change in speed of light causes the refraction of light. So this is the main reason why the refraction happen, why the bending of light happen. So now we'll move towards the next topic. Now this is also very important point. The greater the difference in the speeds of the light in the two medium, greater will be the refraction greater will be the bending of light. अभी 3 into 10 to the power 8 से 2 into 10 to the power 8, the difference is only 1 into 10 to the power 8, but if the difference is more, the bending of light will be more, okay. Now we'll move towards the next topic, that is optically rarer medium and optically denser medium. A transparent substance in which light travels is known as medium, okay. For example, air, glass, or certain plastics, water, kerosene, alcohol, etc. are all examples of medium. And different medium are said to have different optical densities. A medium in which, now listen carefully, a medium in which the speed of light is more, जिस मीडियम में लाइट का स्पीड ज़्यादा होता है, that is known as optically rarer medium, okay. And the a medium in which the speed of light is less, जिस मीडियम में लाइट का स्पीड कम होता है, उसको हम लोग बोलते हैं डेंसर मीडियम. सो अभी हम लोग एग्जांपल देखे थे एयर और ग्लास का 3 इंटू 10 टू द पावर 8 और ग्लास हो गया 2 इंटू 10 टू द पावर 8 स्पीड ऑफ लाइट। सो ग्लास जो है वो उसमें स्पीड क्योंकि कम है इसलिए वो डेंसर मीडियम है, और एयर में स्पीड ज़्यादा है इसलिए वो रेयर मीडियम है। ओके, this I already told you. Air is an optically rarer medium as compared to glass and water. Why? Because the speed of light is more in air compared to glass and water. A glass is an optically denser medium than air and water. Why? Because the speed of light in glass is less compared to air and water. Now the speed of light in water is 2 into 2 into 25 into 10 to the power 8 meter per second, which is less than that in air but more than that in glass. So water is optically denser medium than air, but it is optically rarer than glass क्योंकि glass से comparatively the speed of light water में ज़्यादा है. Okay. Now, the optically rarer medium or optically denser medium can also be defined on the basis of their refractive index. That we will see later. उसमें जिसका refractive index ज़्यादा है उसको denser medium बोलते हैं, जिसका refractive index कम है उसको rarer medium बोलते हैं. That we'll see in the next section. Now let us move towards another important topic, that is refraction of light when it goes from a rarer medium to denser medium. अगर रेयर मीडियम से डेंसर मीडियम की तरफ में लाइट एंटर कर रहा है तो वो बेंडिंग कैसे होगा? So very simple. This already you have studied in the lower classes. When a ray of light goes from a rarer medium to denser medium, it bends towards the normal. Normal की तरफ वो bend होता है. We'll see the diagram. See this is the glass. ये glass है और this is the glass and the light is coming from A, right, incident at point O. Now this is the straight path. ये वाला जो dotted line है वो that is the straight path. But now the speed of light is different in the glass, so it will bend towards the normal. ठीक है, right? So whenever we will study about the bending of light with respect to any two medium, if the light travels from rarer to denser medium, for example air to water, air rarer medium हो गया, water denser medium हो गया, so in that also we'll get the same type of bendings. Okay, so the adjoining figure shows a ray of light AO going from air that is rarer medium into glass, which is a denser medium. In this case the incident ray AO gets refracted at point O and bends towards the normal. Normal यहाँ पे ये वाला है ON is the normal, right, and it bends towards the normal की तरफ bend हो रहा है and goes in the direction OB inside the glass slab. Thus when a ray of light goes from air into glass, it bends towards the normal at the point of incidence. In this case the angle of refraction R is smaller than the angle of incidence. Obviously diagram से हम लोग देख सकते हैं this angle is greater than this angle, that is angle of refraction is smaller than the angle of incidence. Water is also an optically denser medium than air, just now I told you. So when a ray of light goes from air into water, it bends towards the normal. Thus the refraction of light on going from air to water is also similar to the refraction of light from air to glass. Now we'll see the reverse one, refraction of light when it goes from a denser medium to a rarer medium. So glass से air की तरफ आ रहा है, so it will bend away from the normal. उल्टा होगा, वहाँ पे bends towards the normal था, यहाँ पे bends away from the normal. So when a ray of light goes from denser medium to rarer medium, it bends away from the normal at the point of incidence. So take an example. Again हम लोग ग्लास से एयर की तरफ ले रहे हैं. ग्लास से सपोज दिस इज द इंसिडेंट रे AO is the incident ray. So this is the original path, okay, and it will bends away from the normal. So OB जो है वो हम लोग का refracted ray हो गया. The adjoining figure shows a ray of light AO going from glass, that is denser medium, into air, which is a rarer medium. In this case the incident ray AO get refracted at point O and bends away from the normal, that is O n dash, in the direction OB. So we conclude that when a ray of light goes from glass into air, it bends away from the normal. Now in this case, R जो है वो I से बड़ा है, right? The angle of refraction is greater than angle of incident. And water is optically denser than air. So when a light beam of light traveling in water enters into air, it bends away from the normal. So same होगा, same ray diagram से हम लोग show कर सकते हैं when it travels from water to air. Okay, so ये तो था refraction of light when it goes from a denser medium to rarer medium. Now we'll move towards the important topic, refraction through rectangular glass slab. Okay, so glass slab, ये example है glass slab का. So first point of incident, this is the first point of incident and this is the second point of incident. So first point of incident में the light is traveling from denser to rarer medium, rarer to denser medium. यहाँ air से glass की तरफ आ रहा है, so rarer to denser medium की तरफ travel करता है, तो light it bends towards the normal, right? Towards the normal. This is the original path. So OB is the refracted ray. Now point B पे फिर से वो इंसिडेंट हो जाएगा और पॉइंट B का जो OB का जो ओरिजिनल रे ये वाला हो गया. Okay. Now light is coming from denser to rarer medium. So the property, the rule say that it will bend away from the normal. Okay. So ये जो था, ये जो रे है, this is the actual path of the incident ray and this is the final ray. Okay, so इसको original ray बोलेंगे, इसको emergent ray बोलेंगे, and the displacement of this ray, that is CD, it is called lateral displacement. So the light emerges from a parallel side glass slab in the direction parallel with that in which it enters the glass slab. Through the emergent ray, BC is parallel to the incident ray AO, but the emergent ray has been sideways displayed or laterally displayed from the original path of the incident ray by a perpendicular distance CD. The perpendicular distance between the original path of incident ray and the emergent ray coming out of the glass slab is called lateral displacement of the emergent ray of light. Okay, so now lateral displacement depends on the three factors. One is angle of incident, and the second is thickness of glass slab, and the third one is refractive index of glass slab. Higher the value of these factors, greater will be the lateral displacement. Okay, actually lateral displacement is directly proportional to angle of incident, thickness of glass slabs and refractive index of glass slab. Just now I told है ना, जितना ज़्यादा ये factors होंगे उतना ज़्यादा displacement हम लोग को मिलेगा. Okay, right. The angle which the emergent ray makes with the normal is called the angle of emergence, that is denoted by E. Now the case of light falling normally on the glass slab. So if the incident ray falls normally or perpendicularly, normally means perpendicularly to the surface of a glass slab, then there is no bending of the ray of light. It goes straight, सीधा चला जाएगा. Okay, so the O is the incident ray. It will go straight. Again, second incident point में भी वो perpendicular incident हो रहा है, तो भी वो straight चला जाएगा. Right? Now we'll move towards very important topic, that is laws of refraction. So अभी हम लोग दो very important property देखे थे हम लोग when it moves from rarer to denser medium and denser to rarer medium. Now the refraction of light on going from one medium to another medium takes place according to the two laws, which is known as laws of refraction of light. Okay. So according to the first law of refraction, the incident rays, जैसा हम लोग laws of reflection में पढ़े, The incident rays, the refracted rays, and the normal at the point of incident all lie in the same plane. So this is the diagram. So incident ray means AO, incident ray, and point of incident, and the refracted rays are all lie on the along with the normal lie on the same plane. Okay, and the ratio of sine of angle of incidence to the sine of angle of refraction is a constant for the light of a given color and for the given pair of medium. This law is also known as Snell's law of refraction. So अभी हम आप लोग trigonometry पढ़े नहीं है. So sine of angle of incident, it is this short we can denote it by sine I, and sine of angle of refraction को हम लोग short में लिख सकते हैं sine R. Okay, so sine I by sine R is equals to constant, right? This constant is called refractive index. Now refractive index is very important topic, and the refractive index of the second medium with respect to the first medium. This constant is refractive index of the second medium with respect to the first medium. Now let us see the topic refractive index in detail. Suppose a ray traveling in air enters into another medium and gets refracted. Let the angle of incident in air be I and the angle of refraction in that medium be R. So this is denoted by small letter n actually. The value of the constant sin I by sin R for a ray of light passing from air into a particular medium is called the refractive index of that medium. So it is usually denoted by small letter n, and so n is equals to sin I by sin R. What is sin I? Sine of the angle of incident. Sin R, sine of the angle of refraction. Okay, right. So since the refractive index is a ratio of two similar quantities, the sine of angles, it has no unit. This is very important. Now next we'll see the relation between the refractive index and the speed of light. The material or any substance through which light travels is one medium that we have already seen. So light is refracted or bent is going from one medium to another because its speed changes. That also we have seen under the causes of refraction. Due to this, the refractive index, that is n, can also be written as the ratio of speeds of light in two medium. Okay, so this is the figure, and let the medium number 1 as in the speed of light in medium number 1 is v1 and the speed of light in medium number 2 is v2. मीडियम यहाँ पे एयर से हम लोग ग्लास ले रहे हैं, राइट, ग्लास और वाटर. So rarer to denser medium, so it will bend towards the normal. So that property we are using here. So the adjoining figure in which a ray of light AO is going from medium 1 to medium 2 as OB, the speed of light in medium 2 is different from that in medium 1. Then let the speed of light in medium 1 be V1 and that in medium 2 be V2. Okay. The refractive index of medium 2 with respect to medium 1 is given by the ratio of the speed of light in medium 1 and the speed of light in medium 2, and it is usually represented by the symbol n21, or we can write in this way also. So इन दोनों में से कोई भी तरीके से हम लोग लिख सकते हैं. ओके, सो n21 कितना हो जाएगा फिर? Speed of light in medium 1 upon speed of light in medium 2, that is v1 upon v2. Okay. Similarly, अगर हम लोग रिवर्स लेते हैं, मीन्स ग्लास टू और वाटर टू एयर लेते हैं, सो दैट कैन बी रिटन बाय 1 और 2 को हम लोग इंटरचेंज कर देंगे. बाय द सेम आर्गुमेंट, द रिफ्रैक्टिव इंडेक्स ऑफ मीडियम 1 with respect to medium 2 is represented as n12 or 2n1. It is given by this formula. So from this two we conclude that ये वाला रेशियो और ये वाला रेशियो, ये दोनों एक दूसरे के रेसिप्रोकल है. So we can conclude that n21 is a reciprocal of n12. This is very important relation, right? So ये तो था रिफ्रैक्टिव इंडेक्स एंड स्पीड ऑफ लाइट, और कुछ इंपॉर्टेंट फैक्ट्स है इसके बारे में दैट वी आर गोइंग टू सी द टाइप्स ऑफ रिफ्रैक्टिव इंडेक्स। उससे पहले टाइप्स ऑफ रिफ्रैक्टिव इंडेक्स देख लेते हैं। देयर आर टू टाइप्स ऑफ रिफ्रैक्टिव इंडेक्स। द फर्स्ट वन इज relative refractive index. Okay, relative refractive index is nothing but when a light is going from one medium other than vacuum or air to another medium, then the value of refractive index is called relative refractive index. Okay, for example, when the light is going from water into glass, then the value of refractive index will be the relative refractive index of glass with respect to the water. Okay, and the second type is one more. The relative refractive index has always two subscripts with its symbol n, which indicates the two media in which the light travels. रिलेटिव रिफ्रैक्टिव इंडेक्स में हम लोग दो सब्सक्रिप्ट यूज करेंगे। जैसे वहां पर हम लोग यूज किए थे n1 2 दो सब्सक्रिप्ट था, तो रिलेटिव रिफ्रैक्टिव इंडेक्स में हम लोग दो सब्सक्रिप्ट यूज करेंगे। नाउ द सेकंड वन इज एब्सोल्यूट refractive index. So when a light travels from air or vacuum to another medium, then the value of refractive index is called the absolute refractive index. Okay, so absolute refractive index has only one subscript with its symbol n on its right side, which indicates the name of the medium. The word vacuum is not written as the subscript. Subscript में हम लोग vacuum के लिए कोई letter use नहीं करते हैं. Okay, the ratio of speed of light in vacuum to the speed of light in a medium is called refractive index of that medium. That is, refractive index of a medium is called is equals to refractive speed of light in vacuum by speed of light in medium. Okay, since the speed of light in air is almost equal to the speed of light in vacuum, so for all practical purposes we can also say that the ratio of speed of light in air to the speed of light in a medium is called refractive index of that medium. That is, refractive index of medium can be written as speed of light in air upon speed of light in medium. Why? Because दोनों का almost not exactly equal, but nearly they are equal. The speed of light is nearly equal to the speed of light is the speed of light is nearly equal in air and vacuum. Okay, now the next topic is, let us have some numericals based on refractive index. So पहला क्वेश्चन हम लोग देख लेते हैं. Light enters from air into a glass plate having refractive index 1.50. What is the speed of the light in glass? So speed of the light in vacuum is we know that it is 3 into 10 to the power 8. Okay, so यहाँ पे क्या क्या दिया हुआ है? ग्लास का रिफ्रैक्टिव इंडेक्स दिया हुआ है, राइट? तो हम लोग के पास फॉर्मूला है. व्हाट इज द फॉर्मूला? द स्पीड ऑफ लाइट इन एयर, दैट इज वैक्यूम, अपॉन स्पीड ऑफ लाइट इन ग्लास, एंड रिफ्रैक्टिव इंडेक्स इज गिवन 1.5. सो विल सब्स्टिट्यूट हियर. इसके जगह पे हम लोग 1.5 सब्स्टिट्यूट करेंगे और इसके जगह पे जो वैल्यू दिया हुआ है दैट वी विल सब्स्टिट्यूट. नाउ ये दोनों इंटरचेंज हो जाएगा, तो स्पीड ऑफ लाइट इन ग्लास विल गेट 3 into 10 to the power 8 divided by 1.5. So 3 by 1.5 2 होता है. So we'll get the finally the answer is 2 into 10 to the power 8 meter per second. So this is the first question. Now let us move to the second question. If a refractive index of water for light going from air to water be 1.33, what will be the refractive index of light going from water to air? Just now we have seen that n12 is reciprocal of n21. So the same formula we will use here. यहाँ पे air और water है, तो हम लोग उसको ऐसे लिखेंगे n of water with respect to air. Okay, n of water, that is refractive index of water with respect to air is 1.33. Okay, so n of A with respect to water will be the reciprocal of n of W with respect to air. So we'll get 1 upon 1.33, and that will be equals to 0.75 approximately. So this is the question number 2. Now we'll move towards question number 3. Calculate speed of light in water of refractive index 4 by 3 given speed of light in air, that is equals to 3 into 10 to the power 8. Okay. So refractive index का formula हम लोग use करेंगे. यहाँ पे क्या क्या दिया हुआ है, what is given? First of all, refractive index of water is given with respect to air, and VA is the speed of light in air, and we have to find VW, that is speed of light in water. So we will use this relation, right? The ratio is NW is with respect to A is equals to VA upon VW. Now we'll substitute all the values. बिफोर दैट हम लोग को इसमें एक्चुअली में निकालना है VW. सो VW और NW को इंटरचेंज कर लो. सो विल गेट दिस. नाउ सब्स्टिट्यूट VA, that is 3 into 10 to the power 8, and NW, that is 4 by 3. So we'll get the answer 2.25 into 10 to the power 8 meter per second. So fourth example देख लेते हैं. The refractive index of glycerin is 1.46. What is the speed of light in air if its speed in glycerin is 2.05 into 10 to the power 8 meter per second? So यहाँ पे क्या क्या दिया हुआ है? Refractive index of glycerin is given, that is 1.46. उसको हम लोग Ng लिख लेते हैं with respect to A, and Vg, that is speed in glycerin, 2.05 into 10 to the power 8 meter per second, and we need to find VA, that is speed of light in air. So same formula we will use. Ng with respect to A is equals to VA upon Vg. Now we have to find, हम लोग को ये वाला निकालना है, तो इसको क्रॉस मल्टीप्लाई कर लेंगे. Now we'll substitute the values. 1.46 into 2.05 into 10 to the power 8. So we'll get approximately equals to 2.99 into 10 to the power 8 meter per second. So one more example. How much time will light take to cross 2 millimeter thick glass pane if refractive index of glass is 3 by 2, that is 1.5. So first of all क्या क्या दिया हुआ है? The width of the glass is given. That is x is equals to 2 millimeter. Okay, and 2 millimeter we can write 2 into 10 to the power 3 meter, and n is given as 3 by 2, that is refractive index of glass. So we'll use this formula, n is equals to C by V, right? And we need to find first V, speed निकालना है. टाइम के लिए we required speed. So V is equals to C by N. Now what is C? C is the speed of light in air. So that is 3 into 10 to the power 8 by 3 by 2. We'll get 2 into 10 to the power 8. Okay. So itna mil gaya. Now we know that the formula of time is equals to distance upon speed. So x का वैल्यू दिया हुआ है 2 into 10 to the power 8, 2 into 10 to the power minus 3, and v is 2 into 10 to the power 8. If we solve, we'll get 10 to the power minus 11 seconds. Okay, so these are 5 examples. Now I think हम लोग sufficient कर चुके हैं. Now let us move towards some assigned questions. So total 8 questions हैं, जिसमें 3 numericals हैं, बाकी conceptual based questions हैं. So you have to complete these assignment questions, and in the next session we will discuss the answers of these assignment questions, and we'll start the next topic. So that's all for today's session. Thank you very much.